the production of tetraphenyl cyclophenadienone. Once you get used to saying that, you can astound all your friends and neighbors and with your scientific ease. All right, so today this reaction is an aldol reaction. Okay, we're going to abstract a hydrogen from a carbonyl. The hydrogen are alpha to the carbonyl. Once they're gone, the carbanion that's formed is resonance stabilized, so the hydrogen are actually a little bit more acidic than otherwise. We're going to then take that carbanion and attack a different carbonyl carbon, okay? And that's going to create a new carbon-carbon bond through an addition reaction. Okay? However, the product, which is a carbonyl in one part and a hydroxy in the other, almost always dehydrates. So that addition followed by the dehydration, which is going to produce a carbon-carbon double bond, is termed a condensation. So today's reaction is an aldol reaction. It's actually 2 rounds of addition dehydration, so 2 condensation reactions, one after the other. Okay, it's a very nice example of the kind of reaction. Okay, so to do the mechanism, okay, we have our ketone with 4 hydrogen here again that are alpha to the carbonyl and so are acidic, and we're going to treat this with ethynylated hydroxide. Okay. And that will take off one of the acidic hydrogen. Since they're all equivalent, it doesn't matter which one. So we have our carbanion. Once we generate our carbanion, then we want it to attack another carbonyl. In this case, we're going to give it an alpha diketone. That is 2 carbonyls without a carbon in between them. Here again, with it being symmetrical, doesn't matter which one, but as the carbanion attacks that carbon, the pi bond to the oxygen gives. And now it starts to become a bit interesting on how you end up drawing things. So here again, make sure and count carbons. I have the 2, what were carbonyls, right next to each other. I have this one with 1 carbon and then the phenyl ring. And I have some water around that I produced in that first step. But that also produces hydroxide. And I've got that other hydrogen on the same alpha carbon as I took off from before. So I'm going to have the hydroxide pull off that proton. As the hydrogen accepts new bond, it lets these electrons go, This carbon then donates them in the pi bond to that one, kicking the hydroxide out as a leaving group. Now it gets even more interesting on how to draw this. Addition, elimination, all together, condensation. But I still have alpha hydrogen and I still have hydroxide around. So here we go again. You have to really like drawing hexagons. Okay. So now with the generation of a new carbanion, I have an intramolecular aldol addition. As the carbanion here is going to attack our carbonyl carbon there and kick pi bond up. Generates an alkoxide, which here again will protonate because I have water floating around. And then finally, that fourth alpha hydrogen with some hydroxide around. Here again, proton transfer. The electrons then get flipped over to make a pi bond from carbon to carbon, kicking the leaving group hydroxide out. Tetraphenyl, 4 benzene groups, cyclopenta, 5 carbons in a ring, diene, 2 double bonds, own, ketone. Look tetraphenyl cyclopentadienone up in the Merck index, and its one use is often made in organic teaching labs. Why? Because it's an incredibly cool reaction. It's a wonderful example of aldol condensations, because here again it goes through 2, and it's what we're going to do today.